Okay, so this is the second half of lesson 1.2 on relations and functions. And we're going to focus more on functions today. Functions are written with f of x notation, but what f of x means is just that that's the y value of the point. And so we're going to look at evaluating some functions. And I'm going to give you a number to plug in so you can evaluate them. And I'm going to use these three functions over and over so that we don't have to have different formulas for every question throughout the whole problem set, but can reuse some of these formulas. And so as we go through, you're going to be given, like, let's say f of 2. And that obviously tells you to put it in the f of x function, not the g of x, right? Okay. So, okay, let me just take off this slide thing. So let's start with number 1. In this problem, it says f of negative 2. Now again, one of the things you have to be so careful about when you're doing this math is to make sure that you put parentheses, especially around negatives, so that the math gets done correctly. So f has a squared term, so we're going to put that negative 2 inside for that x, and then it has a linear term, so we're going to put the negative 2 in that one. And then we're going to evaluate the problem by working out the powers, doing the multiplying, put the like terms all together, get a number at the end. So we're using order of operations like we always do. You do squared first, right? So negative 2 quantity squared, is that going to be positive or negative? Positive, because it's an even function. It throws a negative away. 2 squared is 4. Times 4 is 16. Then these two negatives multiply to be all positive. And then minus 6. So then I work from left to right, just adding and subtracting the like terms. So that's 26 minus 6 is 20. So the answer to this question is 20. So when you plug in negative 2, you get out 20. That means that would be the point negative 2, 20 on a graph. Does that make sense? Now in each of these problems, we have a variety of different functions. So I'm going to move that up a little bit. So we're going to do g next. G says put in a 3, and that's a linear equation. So we're going to do 5 times 3 plus 2. That's a much shorter equation, no negatives to deal with. You can look at it and say, woo, 17. How did I get that? That's right. First I times, and then I added. So sometimes you can just look at it, and it just comes to you real quick, because there's nothing in there to have to think really hard about. Because there aren't any negatives, there aren't any powers, there aren't as many numbers to keep up with. And then in H, we have 3x squared minus 5. And down here, I wanted to put that in with a negative 2. So 3x squared means I'm going to put in the negative 2 to square, and then the minus 5. Everybody agree with that? So I'm going to square negative 2, and again, I'm doing the same number I did earlier, so I know that's 4 already. Times 3 is 12, and minus 5, 7. What do you think so far about evaluating functions? Easy? All right, why don't y'all try these 3? Before we move on to something else, I'm going to let you try these 3, and I'm going to pause the video while you try 4 through 6. If you're doing this from home, you should pause the video and do 4 through 6 as well. All right, so in looking at it with a calculator, I'm just going to use the h function as an example. I've placed in y equals 3x squared minus 5. So no matter what number now I want, for example, maybe I want the answer for number 6 is 2 plugged in. Then I just go to table setup, tell it start on 2, and go to table. There's the answer. Second window. Now that's one way. The second way, maybe not quite as efficient, but still a good way to do it, would be to store the number on the home screen. For example, suppose I wanted the answer to number 5. I know number 5 is real easy, but just to, well, maybe I better do number 1. I mean, not number 1, but F. Let me move over here to F. Suppose I want to do something with F, and I want to plug in that 3 over there. Well, first of all, in order to do that, I have to realize that if I'm on the home screen, I want the calculator to know I want to do 3. So, I store 3. 3, the store button, X. And it has to be in that order. above the on key. And that's really important. Let the calculator keep up with what x is equal to. Store it. If you don't store it, by the way, it makes up a number. So you better store something if you want to do the math right. And then you just type the problem with the x's. And I always proof it to make sure I typed it right. Now comes the answer. Did y'all get 15 for 4? Now, why this is important is especially when you're doing one like this -2. And here's another trick for those of you who have an 84. Suppose I want to do -2 in that value, and I stored it. And I've already typed F one time, so there's no reason for me to go back and type F again, because I can just go up and grab it. And say, let's do F again. So those are some calculator tricks that you can use that can speed up state testing type things and ACT and SAT, because you can store a number, type the formula, and here's the answer. And if you need to use that formula more than one time, you just go back up there and grab it. You don't retype it because you might make a typo, which is why it's important to prove it the first time, because if you're grabbing it wrong, then it's all wrong every time. All right. Now, so that gives you just a little bit of information about you can use your calculator and be efficient as well. All right, so the next thing we're going to look at is evaluating each function given a value, but these values are going to be a little bit more difficult, because in these problems we're going to put more than one function answer together. This is where your calculator can really come in handy. Now I'm using the same 3 formulas. Does everybody see that? So I'm actually working more than one question at the same time. So this is why I would think knowing the calculator could be important. Because first I got to work out f of -3. Okay, well I still have f in my calculator. Where'd my calculator go? Oh well. At least it'll still be there because it don't empty it when I close it. So I had f in my calculator a few minutes ago, right? Now I want to do f of -3. So I say, whoop. Now I'll come back to it in a minute. -3 stored in x. Now I want to go up there and I want to grab f. And let it rework it with -3. So the answer is 45. So I'm going to use my calculator to do part of it. All right, let me minimize that. So the problem here says do f of -3, right? So I just did that on my calculator, and I got the answer was 45. Now I'm going to go do g of -2. Now, if you can plug -2 in that in your head and do the math and not have to write a whole lot down, I'm okay with that. What's 5 times -2? -10. Add 2. See, if you can plug in a linear one, most of the time you can plug that in and do it in your head. But if you need the calculator, or if you want to, be able to work part of them on the calculator, this page, I feel like sometimes that might be helpful because it'll speed it up a little bit. Then whatever you got done with those pieces, just do the math, which ends up really being 45 minus 8 since 8 was negative. Thank you. All right, let's look over here at our next question. So first it says do 2 times h of -3. Don't I need h of -3 to do that? Then I'm going to do minus 4 times f of -2. And so I've got to work out f of -2. All right, y'all work h and I'll get -2 because I think we did that one a minute ago. That we did on the previous page. We already know it's 20. So y'all get h of -3. Not yet. I just want to know what h of -3 is. 22. And here's why I said I don't want you to times it by the 2. Because you've got some math over here that needs doing. So you might as well only do that little piece for h and f and write it down, and then you can type it all at one time and it'll do all the math for you. So we're practicing our calculator skills on this page, where in the last page we were doing more by hand, just so you can see the difference. Everybody agree? -36. So that's why you want your calculator to work out some of these individual pieces, write down what they are, and then type it all at one time. 2 times 22 is 44 minus 80, which comes out to negative 36. So we're doing it in pieces because we have these functions we've got to evaluate, but when we get done evaluating all the function part, we can type the whole entire thing in the calculator. Our calculator's smart. It knows order of operations. Well, let me phrase that. It knows order of operations for please excuse my dear Aunt Sally. It's not too bright with fractions because that mnemonic does not deal with fraction bar. That's why you have to put parentheses around all fractions. But it's really smart about please excuse my dear Aunt Sally. All right. So let's go to the next one. So here we have a times problem that we've got to work out two individual answers and times them together. And here we have a divide problem in which we're going to do the same idea, but we have to make sure that we keep H on top because it's the first one you type in your calculator when you want to get the answer from divide. So I'm going to give you all a second to evaluate these four functions and do the timesing and the dividing for the two different questions. So take just a minute to work those out. Don't call out the answers. I'm going to pause the video while we do this. So if you're doing this from home, do 3 and 4 on your own. So when you plug these values in, sometimes you can just look at the formula and do it yourself. For example, with G, I can plug 2 in and go 5 times 2 is 10 plus 2 is 12 in my head. I don't need to calculate for that one. But I might need a calculator to help me out a little bit with keeping up with all the numbers with this negative 4 on the F because it has 3 terms. And I got to square it, and multiply it, and add and subtract it. And that's a lot to keep up with unless I'm going to write it down step by step. And that's why storing the value and typing the problem can speed that up just a little bit. What did you get for F of negative 4? What? 78. Okay. All right, so then when you multiply that together, what did you get? 936. Ooh, the numbers are getting big. Glad I didn't have to do that in my head. All right, I'm using G of 2 again, right? So I get to put that 12 back over here that I found over here because I happen to get to use the same value again. But I didn't use H of negative 3 on the previous one, so what was that? 22. Now 22 over 12 does not reduce. Does not divide evenly. So I need to reduce. 11 over 6. Yeah, I meant it didn't divide evenly. So if it doesn't divide evenly, we don't want decimals. That's a no-no. We want fractions. Improper's fine. Don't you think that the elementary teachers spend an awful long time teaching y'all how to make things improper, to mix numbers, and you always wonder, when they get to high school, we don't do that. Well, it does help if you're trying to look at, you have 2 1/3 feet and you want to put 5 3/8 with it. It's a little easier not doing improper fractions, but adding mixed numbers. All right, so we have a couple more. Do these look a little bit more involved? So would it be a really good idea if we write a little something extra down on our paper then, huh? All right, so in this first problem, I'm going to do negative 3 times whatever I get from doing G of 3 in a minute. And then I'm going to add 5 to that. So I need what goes in this parentheses because G of 3 has got to be worked out. Everybody agree? So wasn't G that 5x plus 2? All right, so I can think 5x plus 2 right here. That's not too hard. 17. I think we did that on the previous page, actually. So now I could still do the math in my head if I wanted to, because that's negative 51 plus 5, or I can just type it all in the calculator. Does everybody agree with that? Does that make sense for negative 51 plus 5 is negative 46? All right. Now over here, we've got negative 2 times the answer that we get from F plus 5 times the answer we get from H. So we've got to plug in negative 6 in that quadratic, which could take a little bit of math because it's 3 terms. Now the H function is a little easier because wasn't that just 3x squared minus 5? So we could do that one pretty simple. Wouldn't really need a calculator for that because that's just 16 times 3 is 48 48 minus 5 is 42. 48 minus 5 is 43. So sometimes, if it's not too long a polynomial, you could plug the numbers in yourself and get there a lot faster than typing it on the calculator. But if you got more than 2 terms, it's probably easier to type it on the calculator. For the first one? This one? And, all right, 168? Positive 168? Okay, positive 168 for F. So that's why it's really important to get your calculator to help you with some of these, because some of these numbers do get large really quick, especially if I use numbers bigger than 5. So what was the final answer of this one? Negative 121. All right, so evaluating functions is not difficult, even if they're written in some kind of strange format like this, where you're not just evaluating a function, but also doing other math to it. All right, the next thing we're going to look at is simplifying expressions. I mean, if I can plug numbers in and put things together, I should be able to put things together without plugging numbers in. Now, this is going to go back and review some skills that you already have in a little different format. These are polynomials, right? We should be able to add, subtract, multiply, and divide polynomials. We were taught that in Math 1, Math 2, Math 3. But this is with function notation, so it looks a little different. But once you get past that first step, it'll look like something you know. I mean, let's think about it. If I say add f and g, aren't you going to add the x's and add the constants together? Okay, that's what we're talking about. Adding like terms. All right, so here's our first problem. F of x and h of x are going to get added together. Now, f of x has a linear and a constant. H of x has a quadratic, a linear, and a constant. When you do adding or subtracting, let's go back and think elementary school. Your teacher said add 5,492 to 3,982. Did you do that horizontally?
Yes. No. No. Wait.
What did you do? You put them on top of each other such that the ones places are together, the tens places are together, the hundreds places are together. Well, guess what? You do that in algebra too. You can. You can. So I think of the fact that this f function doesn't have a square, but it has a linear 3x and it has a constant negative 1. Okay, well, come look at it. And then on this one, you have 3x squared plus 2x plus 7 would line up because you have a quadratic, you have a linear, you have a constant. If you line up like terms, they add together really well. Why don't y'all add that up real quick while I look at our calculator to see what's wrong. So when adding, it's the same thing. There's nothing that you've done in elementary school that I can't do with letters. Okay? I can do just about anything you can do. In fact, I can even make things improper, mix numbers, and all kinds of things with letters. It may not look improper to you, but it might be. So the key here is there's got to be something that relates. So when you add whole numbers and decimals, you always line up all the place values. Well, I'm lining up my place values. Here's my quadratic place values, my linear, and my constant. I didn't have any quadratics, so it stayed there. But I had some lovely linears here that made. You know, one time I asked students, I said, how many x's is that? And they said 2. Is it 2 x's? No. Because there's 3 of them, there's 2 of them, that makes 5 of them. And what does negative 1 and 7 make? All right. So now let's try a subtraction problem because it's a little trickier with subtraction. Let's think back to the first time you dealt with positive negatives. You've never subtracted positive negatives a day in your life. No more than you flip and multiply, right? It's division. So let's think about that. What did the teacher tell you when you first started doing this and you had negative 5, subtract 7? Minus a negative, like minus 7 is like a negative, it is. But what did they tell you to do first before you figured that out? So that makes it a positive, negative 7. You change signs and add, right? So that's what makes it negative 7. She tells you change the signs and add. So you always change what follows the subtraction sign to the opposite so you can add, because we don't really have any subtraction rules. We don't have rules for adding. If two negatives add up to a negative, two positives add up to a positive, and one of each you subtract, take the sign of the largest. So because of that, we're going to do the same thing. Now, G has to go on top. So there's my linear and my constant. Y'all. Sorry if whoever's listening to the video. I just whistled into it. Didn't think about that. All right. So there's no quadratic in the G function, right? Because there's no quadratic in the G function, I still need the column because guess what? Well, no, I might not need the formula. Why do I not need it? That's right. I just noticed I was using F. So I don't need a quadratic column because F only has the linear and the constant. So I line them right up under it. Because I want you to think about it like this. If I wrote it the long way, this would be parentheses around 2x minus 3, subtract 3x minus 1. Does that problem look more familiar written like that? Isn't that what you studied in Math 1, 2, and 3? So instead of changing it to plus and making these the opposite horizontally, which I could do, right? I just say line everything up vertically and change signs and add. That way I've just distributed the negative to everybody in the second row. You always change the second row because the second row is always what's after the subtraction sign. And then you add. Use the adding rules that 2 and negative 3 add up to negative 1 because you subtract, take the sign of the largest. So that's because when you distribute your negatives through this parentheses, it changes everything in that parentheses to the opposite. And that's what you've always done when you've subtracted positive and negatives. You change the signs and add. It's how you had to learn it so then you would know, oh, minus 7 really means negative 7, so I'll just use it as negative. Okay? Just like in this problem, minus positive 3 meant negative 3. And minus negative 1, the two negatives cancel and made positive 1. So it's the same thing as distributing it through the parentheses and add like terms. It's just doing it vertically because you might have more terms to deal with. And the more terms there are, the better it is to do it vertically. But you always change the signs in the second row because it followed the subtraction sign. And yeah, using adding rules. Which in this case, I didn't really add those, did I? Because that's the only time I ever subtract is when I have one side of each, right? Now in multiplying, it's also got some very important things to look at. There's quite a few different things depending on what functions you've got. So I want to show you only one way to do it because there are plenty of ways to do it depending on what you're multiplying together. The length of the polynomials can vary the method. So I would rather show you one way that works for all polynomials and then saying, okay, here's a 2-term times a 2-term, but by the way, a 2-term times a 3-term won't do that. Does that make sense? Because I could multiply these first two together, and I could FOIL them. I could box it. I could distribute it. I can do a lot of things. But if I want to do one of these 2 terms times this 3 terms, then that won't work with FOIL. So I always did it vertically before because I found that worked really well. Now some of you may find that vertically doesn't work very well for you, and if it doesn't, you let me know. Like I've got other ways I can show you, but FOIL is not the best way for what I'm about to show you to do because it won't work on every question. It works on some, and it would work on this one, but it wouldn't work on some of the others that I want to show you. So I'd rather do it the way it would work for every question instead of just some. Now let's think of it like this. Isn't this kind of like a 2-digit number times a 2-digit number? So in elementary school, didn't you do that vertically also? And then you multiply it and add like down the columns? Well, I'm going to do the same thing. So let's pull this up a little bit. So if I want to do G times F, okay, G was, thank you. And F was the 3x minus 1? Okay. All right, so if I want to do these two together, then the main thing I've got to remember in doing these two together is it's like what you did before. Take one digit at a time and multiply it times the top. When you get done doing that, take the next digit and multiply it in. And when you did that, didn't you always scoot in when you started the second row? Think that through. If I'm doing 23 times 49, don't I put 7 carry 2? That makes 20. And when I want to start the second row, 4 times 3 is 12. I scoot in 1. Well, we kind of have to do something similar to that with ours as well. Maybe it's not always scoot in 1. It depends on what power you have. You scoot into the right column. So, what do 2 x's make? All right, then I'm going to have a quadratic column, a linear column, and a constant column. So look at your x's at the front. Figure out what the highest power would be if you put them together. That'll tell you what columns you need, especially considering that sometimes they're not both linear. And that really jumps all over the place, and you'll be putting it in the right column if you label them. Then start with the -1. Do -1 times -3. What will that make? What kind of term is that? So I put that in this column. Then do -1 times 2x. -2x goes in the linear column. Now I've multiplied -1 times everybody on the top. So now it's 3x's turn. I'm going to start a second row. And I'm going to multiply -3 times times positive 3x. Now which column does that go in? That's correct. -9x goes in the linear column. And then last but not least, I will multiply the first two together because that's all I got left. 6x squared. And then I add, because in multiplication, if I had finished this question, wouldn't I add it then? Okay, well I do the same thing with this. So what you do with numerical numbers normally in elementary school and middle school is the same thing you do with letters. Now notice that when I added up the linears, the power didn't change. If you add a linear to a linear, it's still a linear. It's like saying if I add apples to apples, I don't get oranges, right? So if I add x's to x's, I get x's. If I add squares to squares, I get squares. All right. Now division's kind of interesting. And for this class, it's a little bit too simplified, I think. And because at this point in time, they're not really wanting to focus tremendously on this morning doing to the division. Because I might need to synthetically divide, I might need to do long division, I might need to factor. So that's going to come a little bit later in one of our other units. So right now I just want to focus on writing division. Oh, well. Oh, I know I taught that, but so you might not have, if depending on who you had. I think it was taught in Math 3.
Oh, I had like long division. I don't know how to do it.
No, honey. Long division with letters.
I don't even know how to do it with numbers. Me either.
Well, that's a problem because when I do it with letters, if you don't understand how to do it with numbers, that would be a problem. So we'll come back and focus on that one day. No.
Okay. I like doing that part.
Synthetic's great, but it only works for linear divisors. So it would work on this one if this one would divide, because the bottom's got a linear divisor, but it does not work to divide out problems that have quadratics or cubics on the bottom. So that's why long division is so better, because it works for everything. Yeah. All right, so we're not going to really focus on dividing or reducing or factoring or any of the things that you should do to a division problem at this point, because most of our problems aren't going to do that, because 3 won't go into 2. So most of ours are not going to divide. Like, for example, if you have a quadratic and you try and divide it into a linear, you don't even have enough x's to divide into. So that's what's going to happen on a lot of these. You're just going to set up the division and you're done.
That's it.
Yeah. Now later we'll go back and we'll look at a little bit more in depth on that. But for right now, that's all we're going to see pretty much most of the time, is it's not going to divide. All right. Same 3 formulas, right? That was number 4, the division problem. I did. I wrote it down right there. That's the problem. That's all you do. That's too easy, isn't it? All right, so here is 4 problems I want you to try. Notice that in a few of these, they're asking you to do a little bit more than the last time. Like this one. I got to do 4 times h, and then write it down on the first row. And then I got to do, well, I guess I could multiply by -2, and that'd help me out tremendously because it wouldn't be a subtraction problem anymore, right?
Right.
And then I could write that on the second row. And then I could add like terms. So it's really important in these questions that you times anything that's in front of it. And because it's an adding or subtracting problem, if you times by the -2, it automatically makes it an adding problem because you've already distributed your sign. And then down here on number 8, you're going to have to multiply the bottom one by -2 as you set it up. So why don't you work these 4 questions, and if you're watching this from home, stop the video and do these 4 questions. So on number 5, did you get 5x minus 4? And does everybody agree, whether you do it horizontally and you distribute the negative through here and add like terms, or you do it vertically, you still get this answer for number 6. So, you know, you can do them horizontally, but multiplication works vertically, so that's why I usually teach adding and subtracting vertically, so you can work with everything vertically. And then let's look at number 8 instead real quick. So 3x minus 1's on top, and on the bottom you have -6x squared minus 4x minus 14. Everybody agree with that? Minus 4x minus 14. Alright, so that just leaves us with number 7. In number 7, they said put h of x on top and g of x on bottom. And in the multiplying, I never pay attention to that. I always just put the longer one on top. Because if they said g of x times h of x, I still would have put h on top. Because it's longer. Does that make sense? This over -6x squared minus 4x minus 14.
So you don't divide.
You don't divide it. Alright, so the last one was this one. And you have 3x squared. What was that problem again? And we're multiplying that by 2x minus 3. Alright. So in this problem, first we're going to do -3 times everybody. So it's -21 for the constants, -6x for the linears, and -9x squared for the quadratics. But when you do 2x times 7, that's 14x, and that goes in this column. Then you do 2x times 2x, and that's 4x squared because you add the powers when you multiply. And then you do 2x times 3x to the third, that'll be 3x squared, and that'll be 6x to the third. And then you add. So 6x to the third minus 5x squared plus 8x minus 21. Alright, so there's some more on Canvas. Still can't complete the whole entire assignment for 4.2, but you will be able to complete up through the part that does this. And I have to hook it up still, but it'll be in there in just a few minutes after we get started on the quiz. I'll hook that up. Alright, let me stop this video.